So we're going to do today the worksheet. On the worksheet, you had 2 of them. And so, sorry, I had to find my timer. I want to make sure I don't go over the time. Okay, so we're going to be only doing the Boyles Law handout today. So I've kind of done 2 of them already, but then I have 2 left that I'm going to do with you. So the first thing that I suggest you do is I personally would get 2 markers so that you can do one for, let's pull this up. One, you can use a color for the pressure, one to use for the volume, and then you can go through and do that. So I've done them both, one in my book and on my paper. So the first one says it's 22.5 liters of nitrogen at 748 millimeters of mercury is compressed to 725 millimeters mercury and a constant pressure and temperature. What is the new volume? So the first thing you're going to do is say, all right, I know liters have to do with pressure, and I mean volume, and I know that ATM, torr, all that has to do with the pressure. So when I go on here, I say, all right, so 22.5 liters is my first volume. My first pressure is 748 millimeters of mercury, and then my second one is 725 millimeter mercury. And then I say, all right, I have P1 V1 equals P2 V2. What do I want to find? I need to find V2. So to do that, I have to divide both sides by P2, which marks that out. Okay, so then I actually go in and I put the equation 748 millimeters of mercury times 22.5 liters divided by 725. So, calculator, you're going to do your alpha y enter. You're going to do your 748, and then we're going to times that by our 22.5. And then we're going to take our 725, and we're going to do that, and we get 22.21. Now, there's one other step that I did not tell you yesterday, but I want you to do. If you see there is a number here, it's called a check number. And so what a check number is where you take your information that you get, your volume 1 and your pressure 1 and your volume 1, and you multiply those together, you get 1683.30. Then you take your 725 times the answer that you got, and you should get 16,830, and that's my check number. This check number is to assure that you have the answer correct, okay? So this is the thing. If you go and do the extra step, you know you make 100 because it should be the same answer on both sides. So then let's look at the next problem. The next problem says that we have a 4.0 liter volume at a pressure of 205 kilopascal. It tells us the volume is at 12.0 liters. What is the pressure? So we're looking for P2 here. So what I did first of all is I went through and highlighted it, and I write down my variables. So then I'm going to do my V1, P1 V1 equals P2 V2. I'm looking for P2 here. So I'm going to divide both sides by V2. Because if I divide them both sides, that's going to be the way that my equation is. So my P1 is 205 kilopascals, and I'm going to multiply that by my V1, which is 4.0 liters, okay? And I'm going to divide that by my V2, which is 12.0 liters, all right? And I'm going to get my answer. So let's see. Alpha y enter. Open bracket, 205, close bracket, open bracket, 4.0, close bracket, down. Open bracket, 12.0, close bracket, enter. And I get, for my pressure 2, I get 683333. Repeating, okay? So since I already have P2 already done, what I'm going to do now to get my check answer, I'm going to do second answer, and that's going to give me the prior answer, and I'm going to multiply that by my V2, which is 12. And I'm going to get 820. So what I did is I took this answer, 68.3333, and I multiplied that by my 12.0 liters, and I get 820. So now what I'm going to do is I'm going to take my P1, right, and it's 205 kilopascal, and I'm going to multiply that by my V1, which my V1 is 4.0 liters. So 205 times 4, that gives me 820. So guess what I'm going to do over here? First of all, I'm going to go ahead and say my P2 equals 68.3333, and that is going to be the units of kilopascal. And then I'm going to go ahead and I am going to put my check answer, and my check answer is 820. 820 block with the check. Okay, so then the next one says, what is the pressure required to compress? So it says that it's 160 liters of air, and that is at 1 atm, and the cylinder whose volume is at 26.0 liters. So I'm doing this so I can make sure I understand what everything is. So number 3, the first thing I'm going to do is I'm going to do my P1, right, V1, P2, V2. So if I'm looking at pressure first. Well, the only pressure that I have is right here. But it says what pressure is required to compress. So then I am looking at air. So I'm looking for what pressure is required to compress 196 liters of air at 1 atm into a cylinder whose volume is 26 liters. So I know that my second volume, right, is in 26.0 liters. I know my first volume is 196 liters, and I know my first pressure is at 1 atm. So then what I'm going to do, P1 V1 equals P2 V2, my formula. I am looking for P2, so I'm going to divide both sides by V2, right? So then, based on that, my equation for number 3, and I'm going to put P1 equals 1 atm, V1 equals 196 liters. I'm going to do P2 as a question mark, and V2 is 26.0 liters. I'm going to do my P1 V1 over V2 equals P2, because that's what I'm looking for. So my P1 is 1 atm. I'm going to add that, multiply that to my volume 1, which is 196 liters. Sorry, and I'm going to divide that by my V2, which is 26.0 liters. So I'm going to go ahead and do alpha Y, enter again. I'm going to do 1 atm times 196 liters, right, over 26 liters, which is going to give me 7.538461,538. Now, that is going to give me my P2. So what I'm going to do is I'm going to go back to my original equation with my P2. So I'm going to do my second answer, and I'm going to multiply that by my V2. Well, my V2 is 26, right? That gives me 196 as a check answer. So now what I'm going to do is I'm going to go back and I'm going to take P1 times V1. So I'm going to do 1 times V1 is 196. Guess what? That's 196 too. So over here, I'm going to say my P2 equals 7.538461,538, but I can actually change that to 7.54, right? And the units for that would be atm. So that is the answer to the question, but my check answer is 196. Okay? So then let's look at the last one. The last one says that we have 40 liters. Okay, 40 liters is my pink. A tank of ammonia that has a pressure of 12.7 kilopascal Calculate the number of ammoniums that have a pressure change to 84 kilopascals. What temperature remains constant? While the temperature remains constant. So for number 4, P1 equals V1 equals P2 equals V2 equals. So I'm going to look again. Read again. A 40-liter tank of ammonia. So I know that when we're talking about liters, we're talking about volume. So it's 40 liters, okay? Well, it has a pressure, that's my first pressure, is 12.7 kilopascal. And then my final pressure is 8.4 kilopascal. So I'm looking for P2. So I'm going to do P1, V1 equals P2, V2. Well, I'm looking for P2, so I'm going to divide both sides by V2. So my new equation now is P1 V1 over V2. Plug my numbers in. My P1 is 12.7 kilopascal. My V1 is 40 liters. And I'm going to divide that by my V2. And my V2 is 8.4 kilopascal. Okay? So when I get done, I should have liters, right? Kilopascal divided by each other. So if I do alpha y, enter, and I say, all right, I have 12.7, and then I have 40, and I divide that by 8.4, and I'm going to do enter, I get 60.47619048. Well, I want to go ahead and get my check answer. And so to be able to get my check answer, I'm going to take this answer, which is my P2. And what am I going to multiply that by? My P2 by my V2. So I'm going to take this answer, second answer. I'm going to multiply that by my P2. That's my P2 times my V2, which is 8.4, and I get 508. Now I need to go take my pressure 1 and my volume 1, and that gives me 508, so that is my check answer. So I hope you have a good day. I think I pretty much have given you everything that you need. Remember, your 508 needs to be here because that's your checking answer, and then your real answer is we're going to round that to 60.5, and that's going to be in liters, and that is it.